Hello students, today we will end chapter 11 by this summary. Here we will divide into 4 parts. The first part is about the set language. The set language, we learned what is a set, which is a collection of distinct objects, and the objects inside the set we call elements. And here you'll find some examples, like the set A include these 4 elements, and set B includes A, E, I, O, U, these 5 elements, and set C we have 6 elements inside. And if we want to talk about the number of elements inside the set, we can use n and then bracket the set. So you will have the above examples. Number of elements in set A is 4. Similarly, you have n bracket B is 5 and n bracket C is 6. And we also learned about the symbol. This one is about an element inside a set. So if P is inside the set A, then we write this one. In the opposite side, this is not belongs to, so not an element of A, then we write this notation. And this is the third one about the subset, means a set is totally inside another set, so you will get the subset. And if this B is totally inside A, then you have B inside A. We use this notation. And this is the opposite side, which is not as a set. And we also have some notations or concepts introduced. So first, universal set. What's the meaning? Is a set contains all elements under consideration in a certain context. In the following examples, if you throw a dice, then the outcome is 1, 2, 3, 4, 5, 6, right? You won't have others. So if you have 1, 2, 3, 4, 5, 6 this set, then it is a universal set in this context. And the second one is empty set, which is on another side. The set contains no element. It's the empty set, or we call null set in some terms. And these two will be the notations. And like you can see the G, which is x smaller than 1 and x greater than 6. Because there's no number which is smaller than 1 at the same time is bigger than 1, right? But it's bigger than 6. So there are no element in G, and G will be an empty set. The last one in this set notations or set language is about the Venn diagram. Venn diagram, we just try to construct a rectangle. You remember, the universal set will use a rectangle for the universal set. Like this one. Universal set. And the set here you have A and B. And these are the elements inside A, then you have some elements. For example, you have 1, 2, 3, and 4. So for this case, you will have A, will be have 1, 2, 3, right? And B, you will have 3, 4. And here we also have some other notations, some other concept: union, intersection, and complement. So let me just use these numbers to do some quick practice for you. So A union B means the numbers in A or in B, so you get all 1, 2, 3, 4. Let's say we have 5, 6 here, okay? So we use the then. And A intercept B, so you will get the intersections, right? So like this is 1, 2, 3, 4, 5, 6. Then you will have 3 as the intersection. And this one is the complement of A. So in this context, like you have 1, 2, 3, 4, 5, 6, right? Then not A means the elements in U but not in A. So you will get 5, 6 in this situation. Sorry, not 5, 6. It should be 4, 5, 6. Okay, the complement of A. So we just write the numbers, then you will have everything here, and 4, 5, 6 here. Okay, get it? Some basic notations or some basic concepts about the set. Okay, session 2, or the second part of this video, we talk about how to just extend the idea of the set language in probability. So in junior form, actually in as well as 3, you also already learned what is the collection of possible outcomes. But now, which is the sample space? Okay, collection of possible outcomes. But now if we use the set to represent this, then if we denote the sample space by S, then S will be the set containing all the possible outcomes as elements. Okay, so we get S equal to this one. Okay, so here we can just imagine sample space, okay, will be the set contains all possible outcomes. And the event is the set again. Okay, it is also a set in this situation, and it contains the favorable outcomes, okay, we want to have. So we can have the event is the set contains all favorable outcomes. Okay, and then we go to some definition of probability. Okay, this is not difficult, like the number of elements favorable to E over the total number of outcomes, then you have the probability of getting E. And same as the number of elements in E, and same over number of elements in S. Okay, and to because to extend this idea, because the numerator will not bigger than the denominator, because the denominator must be the biggest number, right? Because it contains all possible outcomes. So you will get this inequality must be between 0 and 1. And for an impossible event, that means there are no number of outcomes favorable to this event. Then you have P equal to 0. And for the certain event, I mean it must happen, so it is 1. So this is also a quick check, okay, about whether when you want to find some probability, if it is not between 0 and 1, then it must be a wrong answer. And this actually happened to some of your answers, okay, when we are checking the quiz and also the assignments given to you. Okay, and for the note, any two events, then this is just we represent A union B. A union B means the event either A or B occurs or happened. Okay, like you just in the Venn diagram, the concept is the same. And for A intercept B means you need to have both A and B occur. And A dash is the event A does not occur, so that means the complement of A. Okay, And then we go to section 3, which is addition law. Addition law, one very important concept is whether it is mutually exclusive or not. If two events cannot occur at the same time, they cannot occur at the same time, then they are called mutually exclusive. It means that there are no common elements between them. Okay. So, like if you use Venn diagram, mutually exclusive. Okay, must be like this. Okay, you won't have any intersection. So in these situations, PA union B must be PA plus PB because there's no intersection. Okay, so you just imagine by using the area. Okay, as well. So for more than two events, if they are still mutually exclusive, then you just separate them. Okay, so PA1 union A2 union A3 up to AN will just equal to the PA1 plus PA2 up to PAN. The second one is about non-mutually exclusive. So non-mutually exclusive. That means mutually exclusive. Mutually exclusive. So that means if you have a look, they can occur at the same time. They can occur at the same time. So that means there must be some situation they can occur at the same time. That means there are some elements, okay, belongs to both of these sets. So there must be some intersection here. Then this is non-mutually exclusive. So in these situations, we can imagine 4 cases. So you have A and B, right? So you have the PA here, and you have this is the PB, and if this is PA union B, then you have all of them, right? And here we have P A intercept B, and it is this. Okay, so in these situations, you can imagine PA plus PB. Then you will have the middle one, okay, of curves, both, right? Twice maybe. That this does not. So PA plus PB, is it equals to A union B? No, in this situation, because this you have cut both twice, but this you only have one, right? So you have to add one more here actually. So you will have P A intercept B. So this is true for a non-mutually exclusive event. And actually, this is also true for mutually exclusive event because the last one is 0 if they are mutually exclusive. So from this one, okay, finally you will get this. This is also very important formula for probability. And for the last one, complementary event, actually this is not difficult. The complementary event, okay, is just some notation. And then, because the complementary event is A or not A, so if A is not happen, then not A will be happen, right? So PA plus PA dash must be 1, right? Sorry, I'm not very clear in this way. Let me just move a little bit to the next part. Okay, just move here. So you have PA plus PA dash must be 1, right? Because okay, this must be true, right? Either A or not A, okay, then it must include the whole universal set. And these two must be mutually exclusive, so you can just use the first theorem, okay, to find the answer. And then you will finally get this 1 minus PA. And this actually, I think you should already practice a lot, okay, on using this skill, right? In many questions we have shown you before. And now we go to the last rule, which is multiplication law. First of all, okay, we need to understand a concept which is independent event. So if one event is not affected by the occurrence of another event, then they are independent. And in these situations, you will have PA and B equal to PA and then times PB, okay, the probability of they occurs, and then you multiply together. And you have more than one, similarly, you will get this one. Okay, and for the second one, dependence event, it means, on the other side, event B will be affected by the occurrence of event A. Then they are dependent. And this notation will be used, okay, PB given that A occurs, okay, this one is probability of B given that A has occurred already. Okay, it's happened already. Okay. And in these situations, they are not a totally different concept. Okay, P and B. Then you have PA first, and then for the previous one you multiply PB, but now you still multiply PB, but given that A occurred already. Okay, still PA times PB, but the second one you already have PA. And from this rule, it will directly, okay, come to this one. Okay, just move the PA, okay, to the other side. Okay, so if you ask me, this one is more important, or is you need to remember. Okay, for the first one, you don't need to remember, okay, as an extra one. You just use the first one and extend the idea. But for the second one, you must remember, okay, so that you can make use of that in the quiz or examinations. And for the last look, A and B are two independent events. Then PB given that A is equal to PB, as I said, okay. No matter whether A is occurred or not, it will not affect the probability of getting B. So PB given that A is equal to the probability of getting B. Okay, that is simple. So okay, here we finish the revisions of this chapter. So we still need some practice. Okay, this is not a easy questions, like some you still have like very many situations happened. Okay, you need to try to investigate, okay, or try to think, okay, in different situations. It can be very complicated. Okay, let's discuss more after the school resume. Okay, we are looking forward to see you. Okay, so next time lesson we will start Essex chapter 1.